Hello everyone. So the last and final one is here. So basically the u is greater than root 2 gr and it is less than root 5 gr. So what's going to happen here? Let's discuss this in detail. So it's pretty easy actually. So before going to start this certain case, I would like to make just brief. I would like to brief about what we discussed so far. Okay. So let me assume that I am giving an initial velocity u. If u is greater than root 5 gr, no doubt. So we know that this particular one will, yeah, it will complete the circle, vertical circular motion, then which is called looping the loop or completing the loop, right? So if the velocity is the initial velocity which is given, if it is equal to root 2 gr, then what will happen? So it will reach the point B. Okay, then tension and velocity becomes 0. That's it. And if it is less than root 2 gr, then you know that it will be velocity will be 0, but tension wouldn't be 0. So then it will be undergoing oscillation between P and P dash, in between A and B, right? Yes, the point P will be between A and B. So now the question is, what happens if velocity is greater than root 2 gr but it is less than root 5 gr? One thing it is very clear, in between B and C, the body's tension will become 0. So the tension becomes 0, but what about velocity is not equal to 0? Velocity is not going to be 0 because we know that what is velocity? U square minus 2gh root of under root. So the thing is, here velocity will not be 0, but tension will be 0. So what's going to happen to the body? That's what we are going to see, as you can see in the next image. So I'm just giving here, you can see, look at it, this is the body at point P. So here the velocity vector is given in this direction, V. So at point P, you can see that, so the tension is 0, so that is why it will follow a certain path. As you can see, it will follow a parabolic path. So it's totally going to be a projectile motion. It's going to be a projectile motion, and we are going to analyze that projectile. I repeat, we are going to analyze that projectile because we already know what is a projectile, right? So how the conditions of a projectile also we know. So in order to do that, I would like to go to the next diagram. Yeah, as you can see here, so this is the most important one. And what I'm going to do is here, like look at this in the previous one. Here, this is my reference frame. This is my choice of origin. As you can see, this is my y-axis and this is my x-axis. So I consider the y-axis, x-axis in this direction. So as you can see, so this is the velocity and velocity is in this direction. So it's going to be a projectile. Look at this, because the path followed by the projectile is totally determined by whom? The gravity. There is no other force here. So apparently there is no other force in consideration. So that is why it will be same. So now I'm going to go in detail about this. Let's see what we can do. All right. So I assume that there is a point here, P. So I'd like to take another color. Yeah, let me take blue. Okay, fine. So let's say this angle is phi. As you can see, this angle is phi. And then this angle would be phi again. So basic geometry. So now what about this one? This will be 90 minus phi. Why? Because you can understand that this is, yeah, look at this. This is tangential velocity and the radius vector. Always it will make 90 degree. So the point is it will be 90 minus phi. All right. So now the velocity, look at this. The velocity vector is making 90 minus phi with the horizontal. That's enough. That's enough for a projectile. So now we are going to deal with this projectile. So also maybe if you want actually you can solve for V. Okay, how can you solve? You have two methods to solve. I use a different technique. I'll tell you one technique which you also try yourself. Okay, so you can apply conservation of energy. You can apply conservation of mechanical energy for point. So total energy point A, make it equal to total energy at point P. So that's, you will get V. All right. So how you're going to make it? Okay, let me just give you. So what I'm going to do is, like, you can pause the video right now. You can give a try yourself and then come back. Okay, I hope you had a chance to solve the question. So now I want to find out V, provided what I'm going to do is like I'm going to apply total energy conservation, I mean mechanical energy conservation here. So at the point A, so the kinetic energy, you know that u is the initial velocity, so half mu square plus potential energy 0. Why 0? You know very well, because I consider this as my reference line. This is my reference line, people. So look at this, or what do you call? You can call it a zero potential energy line. So based on that only I consider the point P. So is equal to, what is the kinetic energy at the point P? Half mv square plus, now the potential energy at that point. Look at this. So basically you can see this distance is equal to r. Okay, I repeat, this distance is equal to r. And how much is this? This will be r sine phi. How much is this? R cos phi. So better I write it here itself. This will be r cos phi, and this is my r sine phi, which is already given there. Okay, so now you look at this. How much is the height total? You can see r sine phi plus r. So it will become, 1 second, yeah. So mg into r sine phi plus r. Or look at this, all m's. I don't want my m. All right. So multiply 2 as well. So u square is equal to v square plus 2gr into 1 plus sine phi. Okay. So now what is my v square? V square is equal to u square minus 2gr, as you can see, 2gr into 1 plus sine phi. This is the v square value, right? So that part is also been, I mean, we have sorted that as well. And one more thing I would like to ask you a question, that is, look at this. Let's say this is the point at P, the mass is there, the mass is there, and here mv square by r is there, right? Mv square by r is there. And also, what about the weight acting on it? It will be mg. And since that angle is phi, as you can see, this will be 90 minus phi. I repeat, this would be 90 minus phi. So what will be the weight component along this direction? Mg cos phi, right? 90 minus phi. So mg cos 90 minus phi, which is equal to mg sin phi. So it would become, this is going to be mg sin phi. So what I'm going to do is, like, at this point P, we assume that the entire tension becomes 0. So what does that mean? Mg sin phi is equal to mv square upon r. Perfect. So m got cancelled. So rg sin phi is equal to, look at this, v square divided by r. Am I right? Sorry, v square. I don't want v square by r. V square. R I'm taking on the other side. So this also I'll be using later. Let it be there. Now let me ask you a question. Look at this. Again, let me ask you one simple question. That is, here, as you can see, 1 second. Yeah. So here, at this point, I want to write the equation of trajectory. So first I want the angle, right? So it is alpha is equal to 90 minus phi. So we know that the trajectory equation of a projectile y is equal to x tan theta, all right, minus gx square divided by 2u square cos square theta. This is the equation for trajectory. This is a normal equation. This is a parabolic equation, right? So what is tan theta apparently? So I can write x into tan phi minus gx square divided by 2u square cos square, I repeat, I'm sorry, tan 90 minus phi. Okay. So it will be cos square 90 minus phi, right? So this will become y is equal to x tan 90 minus phi cot phi minus gx square divided by 2u square, I repeat, 2u square. What is cos square 90 minus phi? This will be sine square phi. But basically this is u square is initial velocity, but here how much is the initial velocity? V square. So I repeat, you never consider this as the initial velocity u. That is the initial velocity of the vertical circular motion. But what is the initial velocity of the projectile? I want the initial velocity of the projectile. So what is that? That is v. That is v, right? So then also I know the v. What is v? V square is equal to rg sine phi. Substitute there. So the final equation becomes y is equal to x cot phi minus gx square divided by, what is v square? Rg sine phi. So r into g into 2rg into sine square phi will be into sine phi will be sine cube phi. So g also got cancelled. So y is equal to x cot phi minus x square upon 2r sine cube phi. So this is the trajectory equation of the projectile. And at least some of you might be thinking that like this is okay, in order to get this equation is also fine, and we are doing this much derivation to make this equation. And how does it help us? Like what could be the question from this? So you can expect in mains and advanced one sort of question, that is whether this particular projectile, like they will be giving a certain condition, okay, certain values also will be provided. So whether this like this projectile, this parabolic path, would it be going through the center C or the initial point A? I repeat the question. Will it be going through center, or will it be passing through the center and A, the initial point? So how do we solve this question? So it's easy actually. So you know that our origin for this particular problem is this one. So based on that origin, what are the coordinates of C and A? We need them. So based on that, like this point 0, 0, what are the coordinates of C and A? So how do we do that? Very simple. You can understand that my x-axis is along this direction, y-axis is upwards. So I can take this as positive. So what is this? This is r cos phi along x-axis. Alright. What about y-axis? Minus r sin phi. This is it. So I'll be writing here. So the center C, or sorry, the origin, the center is C, I guess. One second. Yeah, C. The center C is actually, the coordinates of center C is r cos phi and minus r sin phi. And what are the coordinates of point A? That is the initial point. You can see here. Look at this. What about this one? This is r cos phi. Again, this is r cos phi, right? Yes. And how much is this height? That is r sin phi plus r. But it is negative, downward, right? So the coordinates will become, I can write A, coordinates of A would be r cos phi as usual and minus of r plus r sin phi. So you have to check whether this is actually going through this particular projectile, this equation, this is going through these coordinates. You just substitute over there and get it, and if it is satisfying the equation, then no problem. So that is going through that. So this kind of question also you can expect from this. I hope you understood this part, and I think it is pretty easy. It is pretty much easy. And like I told you, the previous question that I gave, like apply the conservation of energy and get the answer, and you try it yourself, and that's it. Okay, so couple of more videos are there on it. We will be doing it, and we will meet at that time. Okay, thank you.